Hello, my name is Michael Lee, and today we'll be discussing continuous monitoring investigations with AWS GuardDuty. This project was designed to create a cloud-native automated security solution that was really focused on integrating services such as AWS GuardDuty, utilizing Lambda as well as SNS and EventBridge to take the data from GuardDuty, export it into S3 so that I could use Quicksights. But one of the things that I learned along the way and thought about along the way is that I could also take this data and export it to Slack messaging so that you could have external notifications of events targeting your Amazon Web Services. The other area that I was very interested in was the Amazon AWS Detective. What I learned along the way is that when you enable AWS Detective, that you could essentially, it was automatic. Once you set it up, once you enabled it, it automatically imported AWS's GuardDuty events and findings. So you automatically had this deep investigation process to where you could do further threat analysis and also do remediation actions. This framework, essentially, the intent was to address some key challenges. Traditional security products are often limited and difficult to install in a cloud environment. So what I wanted to achieve was having that cloud native, but also having that level of deep integration between the products. So with that said, let's jump right into the implementation. So this project is highly integrated together, and essentially there's a lot of dependencies. AWS GuardDuty, although it could be a standalone product and is a standalone product, for Detective to work, it is dependent upon AWS GuardDuty. As well, for CloudTrail or for AWS GuardDuty to be effective, it is dependent upon the cloud activity and the things that are put into your CloudTrail. To achieve the automation that I wanted to achieve, I had to implement things like SNS triggers to connect up to Amazon GuardDuty, and also to be able to put the Lambda job as a subscriber to that SNS to essentially send to Slack messaging for my security operations to be able to detect it, or to export to S3 so that I could create visualizations within QuickSight. Some of the key phases of this project was the environment setup. The environment setup for me to essentially create this automated, because I really didn't want to rebuild and rebuild and rebuild as I was going through and testing this. I wanted it to be highly automated. So I utilized bash scripts for creation of the Terraform environment. I then used Terraform scripts to create the infrastructure. And then for all of the data integrations, I utilized Lambda functions for exporting data. So essentially, this entire project is infrastructure as code, all except for the last 10%. And that last 10% was around Quicksights. Although you could do implementation with Quicksights after hours of troubleshooting, after hours of trying to get it to work through various IAM roles and various policies, it just became diminishing returns. And so for a function that literally takes less than 10 minutes, so honestly it could probably take 5 minutes to set up manually, I realized that the return on investment wasn't there to make this 100% automated. As I said earlier, the investigation with AWS Detective, that key phase, once you've turned that on, which we do in our Terraform scripts, this is essentially available to you, and we'll jump into that as we go through the demo. As I said, 90% of this project is automated, fully automated. This is an example of the project directory. You have your deployment scripts, your Terraform scripts. I actually have a different project directory because I have a destruction script as well to tear down the environment. And then my Lambda functions are actually stored in the Terraform, but this is just an example. The key value proposition that I found within this is that the efficiency for setting up your security environment. I mean, what took me, I would say, about 20 hours of just research and getting the settings right in terms of IAM and everything. Now the efficiency for building this environment or rebuilding this environment or building it for multiple environments is there. The invisibility that I now have leveraging Quicksights in terms of if you wanted to create heat maps or whatever you wanted to do with the data from a GuardDuty perspective, now you can have visibility at different various levels within your organization, as well as the scalability, the use of Terraform and being able to scale this up, and also having what I would consider somewhat of a resiliency program through that. Just paid dividends on that. And then the insights I found with AWS Detective is really interesting. The key thing with AWS Detective and what you'll see later on is that GuardDuty comes with some sample findings, but AWS Detective doesn't take advantage of those. So I actually had to have this set up for a few weeks until I had real events come in to where I could do investigations. Unfortunately, those events aren't there anymore, but you will need to set this up for a period of time for you to take advantage of it. The key lesson learned, and I alluded to this earlier, was that balancing the full automation with practicality on Quicksights. Where was the diminishing returns after 4 hours of just beating my head against the wall trying to get this to work for 10 minutes of worth of configuration? It just wasn't worth it. The other area that was really a lesson learned is that, you know, IAM is somewhat of a trial and error. Trying to get your permissions working was really difficult. The third area that I also was here is I originally wanted to utilize Glue for an ETL job to export my GuardDuty findings from an S3 bucket and then do a data transformation and then import those into Athena for Quicksights to be able to run. And this was going to be the automated solution for Quicksights. The challenge that I ran into was that I could not get Glue or Lambda to truly function with the roles, and this is the one where I spent a day and a half just working on the roles, and I finally pivoted and did a Lambda job to do the data transformation, and then just did the manual process that I talked about with in terms of Quicksights. So with all of that said, let's jump into a demo. So as you can see, currently my Lambda, I have 0 Lambda functions. GuardDuty is not enabled. Detective is not enabled. I have 2 S3 buckets that were there before. I also have 0 SNS jobs and 0 event bridges. And I'll talk about event bridges here shortly as I get into this. If you look at my Visual Studio, you can see that this is the setup of my project directory. And this is my deployment script. Now, my deployment script is a bash script, and this bash script is essentially set up to, first, the bins. It's targeting where are my binaries for Terraform. I'm not in a standardized directory, so I needed to understand where those were, define where that is. So if you have this in your path and you're going to replicate this project, you can just get rid of this, or you can just put your path here as terms of an environment variable. I had to set up a Terraform directory since this is a subdirectory out of the directory that I am working in, and I'll just provide a little glimpse of that. You can see that it is a subdirectory right here. You need to define that. There were some other areas that I was working in with alert handler. This was more around GuardDuty and automating GuardDuty. That's when I found out I didn't need this. So this alert handler is some leftover code. But the next set of code is really around setting up my Python scripts for essentially Lambda functions. And so you can see I have a Slack one, I have an export GuardDuty script, and I also have investigate findings, and this was for, again, the detective function. I had to define some variables for these zip files as well, because what happens with when you use Terraform and you're integrating with Lambda is that you need to essentially send your file upward to Lambda to take advantage of, and I just zip these up for compression and send those up because I'm sending quite a few files. Essentially, when you look at this this bash script, it is zipping up those files just mentioned, just letting everyone know that these files have been created. And then we're initializing the Terraform script. Now, the Terraform script, as you can, we'll jump into the Terraform directory just to give you an idea of that structure. Terraform directory, there's quite a few files here. The main files to take into consideration are the variables.tf. The variables.tf define the region that you're using. It defines the email address that you want your alerts set to. It defines your AWS account ID as well as your Slack webhook. Now with Slack, for you to receive the messages that are created, you need a webhook, and that you define that here, and you're going to have to set that up into Slack. I do explain how to do that within this project, although it's outside of AWS and recognizing that. My Terraform script is quite big. As you can see, it's about 700 lines of code. And we will go through that 700 lines of code, but essentially we start out by setting up and defining our providers, and our providers are essentially, think of it as imports almost for Terraform to understand how you would use. So if you're familiar with Python and you would import a library or function, this is the same thing. Here we're importing AWS and we're defining the variable region. As well, we're importing Terraform because there's a point where I have to create a sleep function, and that sleep function is so that I don't break part of this script. When I go through, we are going to define some of the variables. So the variables here are the AWS caller identity. That is me, essentially what I call it, or you when you're calling it. As well as the resource, the time sleep that I mentioned earlier. I have two random strings. One's around bucket ID so that we have, our buckets when we create them. They are unique, as well as our Lambda code. Enabling the services. So I mentioned earlier that, we only have to enable GuardDuty. We only have to enable AWS Detective. These are the resources we are defining, GuardDuty and Detective, and as you can see, we are enabling those within this. CloudTrail is also one that is kind of, we are highly dependent upon. And so this is, we're defining the resource, we're defining it as CloudTrail monitoring. We're declaring an S3 bucket for where the logs go to. We do enable logging, and this is one where we do need that sleep time for this to work. As I mentioned earlier, we need to be able to upload the zip files into AWS. These functions below are exactly what does that. So the AWS object, we're defining the AWS object as export_zip. We're declaring that it's going to go into the AWS bucket Lambda code, which we define later. As well as export the key being the GuardDuty zip file, which was created in our bash script. That key is what's being pushed up to AWS, and then the source is the actual name of the file from your local source. We do an MD5 hash on that. Something that I found interesting about Terraform as I was working with Terraform, and I think you might find it interesting, is it is not a sequential scripting language, meaning I can define my buckets later on down in the code. So even though I'm declaring this bucket here, it doesn't have to already be declared above this section for it to recognize that. So that was pretty cool in terms of things that I learned along the way. Again, this is a lot of what are we doing here. I am defining the Lambda function. So the Lambda function will be named export GuardDuty findings, and it's going to be running Python 3.9. It's operating under the Lambda execution role, which we define later, as well as the naming the handler. And so the handler is the function within the Lambda code that will execute when called. So that Lambda handler, it's almost like main function in a Python code, except we're going to define Lambda underscore handler in that code. And then we have the S3 bucket, Lambda code bucket, that is where this is going to be pushed up to. And it's going to be pulled from the export zip key file. We do declare a couple environment variables for the script to use, and they get attached to the configuration of the script. So this is raw bucket, transform bucket, and the region. And as you can see, we programmatically defined those. So and we defined those as the GuardDuty findings raw bucket, which we declare later, and GuardDuty findings transform bucket. The next is a zip upload for Slack. It basically does the same thing. I'm not going to go through each of these since I went through that above, but you can read and see this, as well as declaring the function and the webhook variable, which we define in our variables.tf. So we do upload the investigate GuardDuty findings. This is for a future project for getting detective working. It is a little bit of legacy code there that I had not removed from the script, as well as the alert handler, which was a part of that as well. We do have on this defining variables an SNS alert topic. The Lambda jobs do subscribe to SNS jobs, and so that is one of the key things that makes our Lambda job work, and that Lambda job is basically triggered off of the SNS scripts, and we'll talk about that a little bit sooner, a little bit later. This is another file that gets uploaded. This is a manifest file, and this manifest file is being uploaded into GuardDuty findings raw. Its key is manifest, its source is a manifest JSON. This is what's needed for the Quicksight to build or to understand where the JSON files are for it to import. And so we will need this manifest file later on as we go through our manual configuration. The following section creates the SNS topics that I talked about. So we're creating an SNS topic called alerts. We're creating an SNS topic called GuardDuty Lambda subscriptions, investigate GuardDuty findings. And as you can see here, we have the endpoint. This is the subscription. The investigate GuardDuty findings .amazon resource name, and that Amazon resource name is essentially how we call those Lambda functions. So we know this is a Lambda function, this is its unique name, and the Amazon resource name is what calls it, or this is its unique variable within the Terraform code. So this is the subscription for Lambda subscription export GuardDuty findings, as well as Slack. So I won't belabor those. We do need to grant SNS permissions. So there was this whole period where I had to play with permissions and get those working. So we do need to set up a resource for the Lambda permissions, the SNS trigger to permissions for Slack. And then as you can see, the action is invoke the function that is allow SNS invoke function, and then the function name is the Lambda functions.slack.arn. And so the principal on this would be SNS, and the source Amazon resource name will be the topic alerts. So, and if you see, all of these use the same topic. And so I have 3 subscribers to one SNS job, and these subscribers do different things. And the different things are: one sends to Slack, One exports the GuardDuty findings and one is yet to be determined. I mean, it does stuff, but given that where I'm at with detective and the limitation on detective for real events, we're not going to be able to see anything out of that. And that was just a lesson learned along the way. So I mentioned earlier that I can declare and describe or create buckets later on down in the code. I didn't have to do it in a sequential manner. This is where we're doing that, creating the S3 buckets within our main.tf. And so the resource AWS S3 bucket name was Lambda code. And so the bucket is essentially Lambda code bucket with a randomly generated string. And then it allows me to force to destroy this. Why did I do this? Because I was tearing up and building this down quite a bit, and it got really old manually clicking things and deleting it. It only took an hour for me to realize that I needed to code, automate everything. And so this was the result of the very large Terraform script and learning that I could do the force destroy. With this resource, I need to define the bucket ownership, and for that. And so, for most of these, if you look, there's the findings raw, there's the findings transformed. I set up versioning. And I did that because if this is a real true production environment, I'm not going to be tearing it down often. And I want that versioning to be there because I may have to come back to those logs, or I may have to come back later on for one of those JSON files, or I may need to later come back. And I needed to understand that those versions were there just from a continuity of operations perspective. I also didn't want my logs to accidentally get deleted because that could come into some compliance issues. I also set up that each of these were encrypted because in the real world, I'm going to want my logs encrypted. So these are AES 256 encrypted, as well as the CloudTrail. So for each of these, CloudTrail, for the Lambda, you had to set up your policies. And so this is the area that I had the biggest trouble in, was setting up the policies to get things to work. I realize as I look through this, I may have some duplication, and I'm okay with that because I got the project to where it was working and I didn't want to mess with it. I didn't want to touch it at that point in time once I got it working. That may be for future, just when I had more time, but I was running up against the wall for submission on this, so I needed to just get it to where it was in a working state. So if you look, this is the AWS 3 bucket policy for the logs policy. It's allowing CloudTrail to write to the S3 bucket for the AWS logs. It is the full bucket owner. We do have CloudTrail permission checked enabled. And so that was for CloudTrail. This is for the Lambda code. So the Lambda execution code. I wanted to make sure that, one, I had the ability to upload, but also for Lambda code to be read. And so this was the IAM role for that. The next group for policies is for GuardDuty findings policy. And so as you can see, this allows GuardDuty to write. This above, just so you know, this allows Lambda to assume role on this, and or allows it allows for Lambda to assume role of the Lambda principal on this for execution. So this is around execution of Lambda functions. So I mentioned it was an S3 bucket. This one is not for the S3. The S3 bucket policy for logs. This is for Lambda execution. This is for GuardDuty findings. This is a bucket policy, so I have some mixed and matched here. I did try to segment these out as much as possible. I just must have missed this one. This is also a Lambda S3 policy. And this is to allow S3 to access the resources on GuardDuty findings and transformed. And as you can see, I allow Lambda to get objects, put objects, and list objects. also to create groups, log stream, and put log events. Getting everything to work was finding out that ChatGPT and I became very close in terms of, here's the error I'm getting, help me solve it. Here's my code. And so ChatGPT was helping me just go through and try trial and error on the different actions and different effects on these policies to get them to work. I'm not going to go through each of these policies. You're welcome to read them on your own. I just wanted to give you an idea of what we were going through. I did mention I would talk about EventBridge. EventBridge allows for, EventBridge is a function that allows for me to pull GuardDuty events into SNS and then allows SNS to push those into Lambda. And so for me to get this to work, I had to set up an EventBridge, and that's purely what the function is here. The resources, the topic policy, the SNS topic alerts. But if you come down here, this is the real meat. This is what allows EventBridge to work. And this is the CloudWatch event rule. EventBridge used to be part of CloudWatch. And so this is essentially saying the source is GuardDuty, and to be able to push this to an SNS policy. And that's ultimately what we end up doing. So, and you'll see this here, AWS CloudWatch event target, and that target is the GuardDuty SNS. So we take the events from GuardDuty, EventBridge pushes them to SNS, SNS has a subscriber, which is the Lambda code, which then does the functions for exporting or sending to Slack. I mentioned that Quicksights, I struggled to set it up. This is some of the policies I was using to get Quicksights to have access to the GuardDuty findings raw and transformed. So one is from the raw, I have to read the manifest.json. So this allows for the list bucket and the get object. But also, a Quicksight needs to be able to read all the JSON files that are exported from GuardDuty and stored in the S3 bucket. And that's essentially what this policy does. It allows for that. This is the Quicksight access role. This Quicksight access role, once you're in this role, you have access to that S3, this policy, and then this policy attaches to the role. That was a lot to say and a lot to talk about. I can happily show you the manifest policy that we talked, the manifest JSON. This manifest is essentially the S3 GuardDuty findings. It points to this. It is a little hard-coded. I need to figure out a way for this to be able to get a variable. So still working on that. The Slack policy or the Slack function. This is the Slack function. Essentially what the Slack function does, it's got the Lambda handler. I think I mentioned that earlier. This is the defined Lambda handler. You have an event and a context. Essentially, we define and we pull in the OS environment variable for the webhook. We use the URL lib pool manager. And so essentially that creates the HTTP object. We pull in the SNS event message. So it's broken up. It essentially is a series of JSON, and you have to dig deep into the JSON to get this. And then what you have is you have this SNS message that's going to be your Slack payload, and essentially you have a response that you post to your webhook handler, and eventually you'll see thousands of messages will come in over Slack saying these are the different events that are coming through. Very similar function within GuardDuty. We do import a few more things such as Boto3, JSON, and OS because essentially the event, the Lambda handler, what happens is we receive the SNS message, we transform it through our parse GuardDuty function up here where I go through, and what I did notice about the messages is some of them have a detailed field, and if that detailed field is present, are not present, then I just want to go through and get the ID, the severity, created at, and type. If the detailed field is present, then all of this data is encapsulated in that detail, and I wanted to capture it there. Regardless, I return this back to the Lambda handler into this transformed data variable. That transformed data variable is then sent to the export transform where we create the JSON files in the S3 bucket. That is a lot to go through the code. Let's look at the demo now. So if you have this, I do have a GitHub. I have this on GitHub, so if you wanted to just pull it down and run it, it is possible for you to do that. But essentially you deploy .shell, it goes through and it is initializing and the Terraform, it's starting to build out the plan, and then it will start deploying out to Amazon. It is not fast, but it is much, much, much faster than doing all of this by hand. And when I say it's not fast, I mean it's less than, I would say it's less than 3-4 minutes. So that is still pretty good. And there you go. It's done. And you can see that we had 49 resources created. Let's just go through and just check some of our configurations and see that, okay, we have 4 Lambda jobs. These are the 4 Lambda jobs that I mentioned earlier. If you look at GuardDuty, you can see that we have some environment variables set. So we can see an SNS topic there. If we go to the export, we see configuration, environment variables, we see that. We see our trigger into SNS. So let's go to our SNS. Before it was 0. We now have 1 SNS topic. We can look and we see we have multiple subscribers. And as you can see, this subscriber is security alerts. This is export GuardDuty. I think the first one, this was Slack. I apologize. So SNS seems to be configured. Our Lambda functions seem to be there. We see from before that GuardDuty and Detective weren't configured. Let's just refresh this screen. And it looks like we do have a GuardDuty function here. So, Detective. This is Detective, and you can see there's no investigations currently. Let's refresh on GuardDuty, and we see that GuardDuty's here, but we see no attacks and nothing in here. Well, one of the things about GuardDuty is that you can go to the settings and you can generate sample findings. And as you can see, this takes a little bit, but it is generating lots and lots of sample findings. So when you generate these sample findings, if you come back to the summary, you can see that, okay, I now have 360 findings. I have 2 criticals. And one of the things about that is if you look, I now have 20 new findings that have just come in from GuardDuty. So let's look at some of the other things that occurred. Within S3, you see that I had 0 buckets. I refresh and now I have cloud trails. I have GuardDuty findings raw. I have the transformed. I have Lambda code here. This is where all the Lambda code is being pulled from. If we look at the GuardDuty findings, you see the manifest.json. And now you also see the GuardDuties transformed. And I have a JSON file here, 101 bytes. So that JSON file, and this will continue to populate due to the generate sample. So let's look at, oh, I mentioned Event Bridge. I didn't have any, or I do have an Event Bridge now. And you can see this is the default Event Bridge, and this is for GuardDuty findings, and it is enabled. So all of this seems to be working. I am able to get here, so let's go to Quicksights. And so for Quicksight, the way you would set this up is you have data sets, and you would do a new data set, S3, and we would call it S3 demo. Now, for this, I need the JSON file that we discussed earlier. So I go to my bucket, go to raw, click on this, copy the S3 URI. I go back to Quicksight, implement that, and let's preview data. And in this case, the JSON file has NA for these types. So what that means is that the data that it was populated into from the script, it's not able to find these fields. So it automatically declares them as NA. If it were able to declare the fields, you would just publish, and from there you could, well, because I tore down that environment, this import has failed. But you would be able to see a dashboard. You would be able to see a heat map very similar to this, which severity and count and things of that nature. So that is my demo all the way through. I hope you enjoyed it. I had an immense amount of fun. Doing this project. It was rather challenging. Lessons learned out of this: spend less time troubleshooting a scenario that just seems overly difficult and try to find a better solution. You know, the ETL job that I wanted to do for Quicksight, I think, is a better solution, but it is a much more complex and difficult solution, and I just was running out of time. I think that would have been a lot cooler on this project, but it is what it is, and I'm pretty pleased with the results that I had, regardless of not able to get that. And again, to set up a Quicksight heat map took less than 10 minutes, and I was well into 4 hours of troubleshooting and saw another 4 in my near future. So it did not make sense for me to continue down that route. The other area that I really lessons learned is understanding the IAM policies and understanding the roles. I think would have made this a lot easier for me in terms of the project if I had better familiarity with how to define those and get those going. But all in all, this was a good project, and I'm actually very pleased that I chose this one. So thank you, and I hope you enjoyed.